16 and 17 we'll do together in this one video. So we're using table F in the text on your formula sheet. Table F is the t-distribution formula here. A quick look at it tells us that if there's a one-tailed test, this table gives us the area to the right of t. But again, this is symmetric as well, so if we have the area to the right of t, we also know the area to the left of negative t. Right? So let's do it. So using table F in your textbook, find the p-value interval for a test value t is 1.945, n is 28, two-tailed. Now if n is 28, we know the degrees of freedom is n minus 1. So 28 minus 1. So our degrees of freedom should be 27, and this is two-tailed. So if we look at our table, we should probably be able to figure most of this out. Okay, so let's see. Let me go back. T is 1.945. Degrees of freedom is 27. 1.945, 27. Okay. So degrees of freedom is 27. Let me scroll down a little bit. 27 here. Right, 27 here. So 1.9, that t value of 1.945. If you notice, these t values are for specific alpha values, right? And we can't, a table would look crazy if we had a t value for every single alpha value, which is possible, but messy. So if degrees of freedom are 27, 1.945 is between, it's between this 1.703 and 2.052. 1.9 whatever is between these two values, right? And if we're talking about a two-tailed test, it's between these two values. 5/100ths on the left and 1/10 on the right. So this alpha value has to be between these two values here, between 0.05 and 0.10. So the p-value interval, so the p-value has to be between 0.05 and 0.1, because this is a two-tailed test, so they automatically give you they automatically double the p-value like we did in the previous problem. So that's the p-value interval there. All right, next, again using table F in your textbook, find the p-value the p-value interval for a test value t is negative 1.145. N equals 5, so the degrees of freedom is 5 minus 1, which is 4. And this is left-tailed. T is negative, so this is definitely going to be left-tailed, right? So again, if I go back to the table gives us, like we said before, the table gives us the area to the right, positive t value, right? But we're symmetric. Excuse me. So if I look for negative 1.145, that'll be the exact same area or p-value as positive 1.145. So I'm looking for positive 1.145. Degrees of freedom of 4. So degrees of freedom of 4. 1.145. So this table, these alpha values don't get large enough on this particular. So I've got to look at a different table. I had already pulled up another table. So I have this other table here. So if I'm looking for degrees of freedom of 4, positive 1.145 would be in between here, Positive 1.145 would be in between 0.15 and 0.2. So our p-value is in between those two values. What did I say? 0.15 and 0.2. Now this region might be narrower than the one in your book for the answer for this problem, but since our table doesn't go that far, then this is our answer here.